For 10 centuries, the capital of the Byzantine Empire, Constantinople, survived behind a 12-mile perimeter of stone. These Theodosian walls were a triple-layered defensive system, featuring a flooded moat, an outer wall, and a massive inner wall standing 40 feet high. Every major empire that tried to break these defenses with traditional siege engines had failed. In 1452, a Hungarian engineer named Orban arrived at the imperial court. An iron founder who specialized in casting heavy metal bells, he brought Emperor Constantine XI blueprints for a siege cannon, a type of heavy artillery used to batter fortifications, larger than anything the world had ever seen. The Byzantine Empire was bankrupt. Centuries of territorial losses and a dwindling population had left the imperial treasury severely depleted. Constantine lacked the liquid capital to pay Orban's high salary, let alone purchase the immense quantities of copper and tin required to cast the weapon. Constantine's decision reflected a failure of cash flow, not courage. In the 15th century, the technical advantage in siege warfare was moving from the mason to the metalworker, and the Byzantines lacked the capital to participate in their shift. Rebuffed by the emperor, Orban packed up his blueprints and traveled 150 miles northwest to the city of Edirne. There, he offered the exact same supergun to the 21-year-old Ottoman Sultan, Mehmed II. Mehmed was actively preparing to besiege Constantinople and grasped the strategic value of the design. He offered the engineer 4 times his asking price, providing unlimited funds and stripping raw materials from across his territories to build the weapon. Mehmed wasn't looking for glory in a cavalry charge, he was looking for an industrial solution. By treating the siege as a procurement project, he turned the theater of war into a testing ground for specialized heavy machinery. This single deployment of capital birthed industrialized firepower, signaling the end for static stone fortresses. Over 3 months in an Edirne foundry, Orban's workers poured liquid bronze into a colossal custom-built mold. The resulting cannon, named Basilic, was a bombard, an early type of large-caliber muzzle-loading artillery piece. It measured 27 feet long and weighed an estimated 16 tons. As this topographical map shows, the Ottoman army had to transport this 16-ton cylinder from the foundry in Edirne to the front lines outside the walls of Constantinople, a 150-mile journey. The entire caravan moved at a pace of just under 3 miles a day. The transport required a massive wooden wagon, pulled by 60 oxen, and flanked by a crew of 400 men operating wooden rollers to keep the heavy barrel from sinking into the earth. The ground itself could not handle that kind of localized pressure. Mehmed dispatched teams of carpenters and 50 specialized engineers ahead of the convoy to reinforce roads and construct heavy-duty wooden bridges across ravines. Early artillery warfare functioned primarily as an exercise in conquering logistical bottlenecks, forcing armies to drag the sheer weight of new technology across uneven dirt. Once in position, the physics of operating Basilic required massive inputs. To generate enough explosive force to propel its ammunition, the artillery crew had to pack the rear chamber with roughly 500 pounds of highly volatile black powder for a single shot. When detonated, the resulting blast produced a crippling mechanical recoil. The 16-ton bronze tube violently jerked back into the mud, forcing the crew to dig it out, realign it, and meticulously reposition the weapon from scratch. Looking at this cross-section schematic of the barrel, we can see how the explosion generated intense heat inside the bronze. If the crew poured fresh gunpowder into a hot chamber, it would prematurely ignite. They had to douse the inside with warm oil, then wait hours for it to cool down. Because of this slow cooling and reloading process, the largest weapon on Earth could only be safely fired a maximum of 7 times a day. Its raw destructive power was matched by its mechanical inefficiency. The siege of Constantinople became a slow, agonizing grind of attrition. When Basilic fired, it hurled solid marble projectiles, measuring over 2 feet across and weighing 1,100 pounds. The black powder charge launched these massive spheres over a distance of nearly 1.5 miles. The collision resulted in a massive transfer of kinetic energy, the energy an object possesses due to its motion. When the 1,100-pound sphere struck the rigid, ancient limestone, the stone couldn't flex. It shattered into a spray of jagged shrapnel and dust. Each night, the Byzantine defenders rushed to the blast sites. They worked frantically to plug the gaping breaches using timber, wooden barrels, earth, and the loose rubble from the destroyed walls. This created a strange physical irony for the defenders. because this hastily packed dirt and loose rubble was malleable that actually absorbed the kinetic impact of the cannonballs more effectively than rigid ancient stone. But human endurance has its absolute limits. The 53-day siege operated as a mathematical equation. The Ottoman cannons delivered a daily output of kinetic energy that eventually outpaced the defenders' physical capacity for repair. On the morning of May 29, 1453, the math caught up with the city. 6 weeks of relentless mechanical blasting had punched holes large enough for waves of elite Ottoman infantry to flood through the defenses. By the afternoon, Constantinople fell. Emperor Constantine died in the fighting, and the city was absorbed as the new capital of the Ottoman Empire. The ruins of these walls are a physical record of the moment the medieval fortress became obsolete. When gunpowder reached this scale, the traditional logic of passive defense, of simply standing behind a thick enough rock, stopped working. Industrialized gunpowder had successfully solved the problem of stone. By proving that a concentrated application of capital, logistics, and chemistry could level the greatest fortress on Earth, Mehmed and his engineer ensured no static wall would ever be safe again.